Hi, in this video, I would talk about phase 2 biotransformation reaction. And phase 2 biotransformation reaction occurs in the cell after phase 1 biotransformation reaction. Phase 1 biotransformation reaction I have talked earlier are really performed by hydroxylation reaction and by addition of sulfhydryl group or amino group. Now, in the phase 2 biotransformation reaction, main reactions are conjugation type reaction. So with the product of the phase 1 reaction, some type of chemical groups are conjugated so that it could become more soluble and could be easily excreted by urine. So first reaction would be glucuronidation. So one good example is bilirubin. Bilirubin is conjugated with glucuronic acid and it get excreted. So unconjugated bilirubin is insoluble, but when it's conjugate with glucuronide, it becomes soluble and it could be excreted easily. And glucuronic acid could conjugate with hydroxyl carbonyl ols or sulfhydryl group. So remember, hydroxyl, sulfhydryl or carbonyl group would be present in a particular drug or xenobiotic after the phase 1 biotransformation reaction, because phase 1 biotransformation reaction basically adds hydroxyl group or sulfhydryl group. And the key enzyme used in this process of glucuronidation is UDP glucuronyl transferase. So it's a transferase enzyme. It would transfer glucuronide group and it is mainly present in endoplasmic reticulum. Next example would be, so here is our drug and we have UDP glucuronic acid, and by the enzyme UDP glucuronyl transferase, this glucuronic acid group would be transferred onto the hydroxyl group of this particular drug. And this drug was biotransformed in the phase 1 reaction. So here we have a detailed example. So here we have aspirin, which is a non-steroidal anti-inflammatory drug. So this aspirin, after phase 1 reaction, acquired a hydroxyl group. On this hydroxyl group, glucuronide conjugation can take place. So in this hydroxyl group, UDP glucuronyl transferase adds this glucuronide group. As you can see, there are many negative charges in this glucuronide conjugate. So as there are many negative charge, this is highly polar and water soluble. So it could be easily excreted from the system. And then another important phase 2 biotransformation reaction is glutathione conjugation. And glutathione conjugation is really important. Glutathione conjugation takes place in all alkyl halide, epoxide and alkanes. And here is our drug, which is actually biotransformed, and it has now a alkyl halide group represented as X. Now glutathione would be attached to this group, and as you remember, glutathione is a tripeptide, which is gamma glutamyl cysteine glycine. So it has a glutamate, cysteine and glycine. So it's a tripeptide. Now after conjugation of the glutathione, the drug would be conjugated with glutathione by glutathione transferase, GST. It's a very important enzyme. After that, these particular glutathione conjugated drug would react with the acceptor, and the acceptor would accept the gamma glutamate group, and now it would leave the glycinyl cysteine conjugate of form of the drug. And this glycinyl cysteine conjugation of this drug is further processed by peptidase, where the glycine is removed and there is a cysteine group only present. And after that, N-acetyl transferase transfers a acetyl group. So here you can see this is the basic cysteine, and after that N-acetyl transferase transferred actually the acetyl group, and whatever you can see now, this is actually the marcapturic acid, and marcapturic acid is highly soluble. So here you can see it is actually a cysteine group with which acetyl group is added, and so it became mercapturic acid, and mercapturic acid is soluble. It could be excreted easily. Another type of important biotransformation reaction of phase 2 is sulfate conjugation. Now, sulfate conjugation takes place when there is a presence of phenolic or alcoholic groups, and sulfate group is transferred from phosphoadenosine transferase, which is called PAPS. So phosphoadenosine phosphosulfate is PAPS, and the transferase reaction actually transfer PAPS, the sulfate group from PAPS to the particular drug and make it more soluble. Another important biotransformation reaction is acetylation. So its acetylation means basically conjugation with acetic acid, and this acetyl group, the source of this acetyl group is acetyl CoA. Drugs like isoniazid, sulfanilamide, like sulfur drugs, are eliminated in this acetylated form. So acetylation is also a very important phase 2 biotransformation reaction. So that's conclude the video on phase 2 biotransformation reaction. I hope you enjoyed the video. If you like my video, give it a quick thumbs up. Don't forget to subscribe, and please leave your comments below. Thank you.